Find the interval of convergence for the given power series. So you got that. How we gonna do this? We're gonna do the famed ratio test, which says the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. Wherever it's less than 1, the infinite series converges, comes to a finite sum. All right, so let's do it. So it's the limit. Right here, let me get a little more room. There we go. Limit n goes to infinity. All right, so we're going to start on the top with a sub n plus 1. So that means I'm going to plug in n plus 1 everywhere I've got n. So that's going to become n plus 1 to the 8, x plus 3 to the n plus 1, 10 to the n plus 1. I'm getting lost, and that's n plus 1 to the 26 thirds. Okay, that was the n plus 1 plugged in. Now we need to that. So a to the n plus 1 goes on the top, and then on the bottom, we're supposed to have a sub n, right? A sub n plus 1 on the top, a sub n on the bottom, which means I can do all this on the bottom, n to the 8th, the regular n, not n plus 1, but the regular n over 10 to the n to the 26 third. But I don't want fractions over fractions. So I'm going to flip this up and multiply by the upside down because dividing is upside down multiplying, as I think you know quite well. So let's do that. Let's just multiply by the upside down. That will put the a sub n on the bottom. That is dividing by the a sub n. So 10 to the n to the 26 thirds, into the 8. Um, yeah, all right. Well, I was going to do a trick, but let's just keep going. X plus 3 to the n. All right, and we want the absolute value of all that less than 1 because that's where it'll converge. Okay. So what we can do? Well, n plus 1 to the 8. This means n plus 1. No, 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 never mind. I'm going to leave that be. Never mind. That we're good with that. This part I'm going to change that. This is x plus 3 to the n times x plus 3 to the 1, isn't it? So let's rewrite that way. Limit n goes to infinity of plus 1 to the 8th. This is x plus 3 to the n times x plus 3 to the 1, right? Same basis multiplied powers add, n plus 1, same-o, same-o. Same thing down here. This guy, this is 10 to the n times 10 to the 1. And then this is n plus 1 to the 26 thirds. Just doing little things I can cross out here. And then what do we got? 10 to the n to the 26 thirds, n to the 8th, x plus 3 to the n, absolute value less than 1. Okay. See what we can do now? We can cross off some stuff. What? X plus 3 to the n, x plus 3 to the n. Is that it? 10 to the n, 10 to the n. All right, that's it. Limit n goes to infinity. All right, so now what I'm going to do is, I'm going to put the x stuff. I'm going to circle or cross out everything so you don't lose anybody. So I'll put x plus 3 up there and 10 down there. Okay, then all the n stuff. So times, then we got all the n stuff. We got n plus 1 to the 8th, circle that, n to the 26 thirds, over, n plus, well, here, I'll put this guy here, into the 8th, I'll put this guy over here. Absolute value less than 1, right? So I circled or crossed off everything so I didn't lose anybody. Okay. Now, what happens as n goes to infinity of all this stuff? Well, we just remember if you're going to infinity, all that matters is the most powerful term. If you go to infinity, infinity plus 1, the plus 1 doesn't do anything. So get rid of the plus 1, get rid of the plus 1. So what does that mean? On the top there, that's n to the 8th times n to the 26 thirds over n to the 8 times n to the 26 thirds. They cancel, right? Because you get rid of the plus 1s because you're going to infinity. Plus 1 doesn't matter. So x plus 3 over 10, absolute value. We don't write the limit anymore. We did the limit. So now we have absolute value of x plus 3 over 10 less than 1. Multiply both sides by 10 over 1 or just 10, same thing. Cancels out. So value of x plus 3 less than 10. What do you do with that? Well, do you remember what that means? That means x plus 3 is less than 10 or greater than negative 10. Remember, that's what we do for absolute value, right? Just think about, like, if I said the absolute value of x is less than 10. That means that number can be between, can be between negative 10 and positive 10. Anything in between, like negative 9, positive 8, all those are good, but not negative 11. Absolute value, that would be positive 11, which is not less than 10. So it's between negative 10 and positive 10. And now just add 3 on through. And, well, why did I add 3? Don't add 3, subtract 3. That was dumb, 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 dumb. Let's try that again. Subtract 3. Realized it as soon as I looked in the middle and thought, those don't cancel. What am I doing? Okay, so that's 7. It's minus 13. So there we go. Minus 13 to positive 7. That was the basic answer to the question. But now we have to check the endpoints. See this, there's those answers. Minus 13 to positive 7. But now we have to check the endpoints. Turns out one of them is going to be a yes, one is going to be a no. How do we do that? How do we know that? Well, I'm going to try to scribble it in right up here if I can. Get rid of this. So okay, so I'm gonna so we got the basic bounds. It goes from negative 13 to positive. But now how about the most? How about right at negative 13? We know it's good, between negative 13 and 7, but can it equal 7? Can it equal the negative 13? Well, you got to just plug those in individually. So I'm gonna start with the minus 13. Do this left one first. That's going to be a yes. We'll see why. So put in right here, minus 13. Correct. What do we get? Into the 8, minus 13 plus 3 to the n over 10 to the n into the 26 thirds, the sum of that. So what does that equal? Well, this is going to be sum of, let's do this. 26, yeah. So 26 thirds. Let's help out with that. 26 thirds. If you divide that on your calculator, it's going to be 8 and 2/3. You can just divide it on Desmos. So it'll be 8.66666. Yeah. You can just check 8 times 3 is 24, add 2, 26. Yeah, anyway, 8.6666. So that means this is on the bottom. So you have into the 8th on the top and into the 8.666 on the bottom. And then right here, this is minus 10 to the n, and then there's this 10 to the n, okay? So then what does that equal? Well, that is going to be, these n's can subtract powers, the bigger one's on the bottom. So that'll be n to the 0.666 on the bottom. Okay, and now what is this? This negative in here, this is negative 1 to the n, 10 to the n, 10 to the n. These cancel. I just pulled out the negative 1 because it's negative to the n and 10 to the n. So pull that out. Okay, and so what does that equal? We're almost there. Equals the sum, negative 1 to the n over n to the 0.666. How do we know whether that converges or not? Well, that's a p-test. Remember that? So this is remember when you have 1 over n to the p? So this is the p. This p is 0.6666. So remember when that p-value is less than 1, right? 0.6, I keep writing that badly. 0. Right down here, 0.666 is lower than 1. Um, that that does not converge absolutely. Remember that diverges, um, except, well, here, you know what? It diverges for positive terms or positive terms, but we don't have positive terms. We have this, which is going to make alternating terms. And so, what do we know? What is the formula for alternating terms? This is an alternating. So for alternating, if it's plus minus, which this is, as long as the terms go down to zero, when the terms, if the terms go to zero, then it converges. Do these terms go to zero? Yeah. You put infinity, you plug infinity in there for n, right? That's, and you put infinity up here, that's just gonna be plus minus, whatever. But infinity on the bottom to some fractional power is going to be infinity, and that's going to be 1 over infinity. That's going to be 0. Yeah. So it's going to converge. So that's why this one's a yes. And that's the same reason the other one's a no. Because for the other one, the only difference is when you put in the other one, you put in the 7. So we just did the minus 13. So the minus 13 is a yes. Why? Specifically because we get the minus to the end. And that's an alternate. It's minus, plus, minus, plus. And alternating, all you got to do is have the terms go down to 0. They do, because we have n to some power on the bottom. Let that go to infinity. 1 over infinity is 0. Yeah, it works. That's all you need for an alternate. They're plus, minus, plus, minus. They subtract each other. So all they got to do is go down to 0. The individual terms go down to 0. And then adding them up forever is guaranteed to converge. So yeah, it works. But how about plus 7? You put in plus 7 instead of 13, put in a plus 7 there instead of minus 13. 7 plus 3 is positive 10. So we don't get this minus 1 thing. We just get 10 to the n over 10 to the n. So we get the same thing, but only positive. No minus anymore. Because 7 plus 3 is positive 10, whereas minus 13 plus 3 was negative 10 to the n. Now we get positive. So now we just get the p series. P is less than 1. That diverges. We only have positive terms. That's why that one's a no, right? So these terms go down to 0 individually, yeah, but when they're not going there fast enough. If the p-value is lower than 1, 0.666 is lower than 1, that means it diverges, right? You want bigger powers in the bottom, bigger than 1, like 2 or 3, because that means the bottom is bigger, the overall fraction is smaller. It gets small quick enough so you can add them up forever, still get a finite sum. We can't. These terms are too small. P-values, power's too small. This diverges. That's why that one's a no. And so there we go.